Hello, my name is Khalilulla Mohammed Abdul Raheem. I'm here to introduce my project. My project is multi-attribute decision making. So our topic is flood potential in Texas by county. So as I talk about motivation of this project, motivation is like Texas is prone to flooding. Flooding damage public properties, infrastructures, and threats human safety. We have mapped flood potential to help decision making, and urban flooding is really critical due to the amplified damage. So in this project, we'll use the MCDM technique to rank the Texas county based on the flooding potential. We have parameters to quantify flood potential for each county. So the first one is rainfall. Rainfall is the main driver for flooding, and we use the precipitation pattern in our project, and also use 30 year prism data, and the ArcGIS is used for calculating our zonal values. Then the second one is elevation. We have a 30-meter national elevation data set, and is a part of 3D elevation program of USGIS. And another one is slope. We'll calculate the slope using slope tool in ArcGIS, and that tool is basically determine the greatest rate change in the cell and the neighbor cell. And the third and the fourth one is percentage impervious. That data is retrieved from the land cover map prepared by MRCL. And the last one is population density information for each county extracted from the census.gov for census 2020. As I
Hey, I'm Aalok, and I'll continue with the next part of our project. So, since we are creating a topsis model using the MCDM technique, we need three things. One is the criteria. What are the criteria we're ranking our alternatives by? So, the second is alternative. And how does that criteria weigh in the parameter of interest? So, how does each of the criteria that Ruhan just talked about impacts flood? So, let's start with rainfall. Since rainfall is more rainfall means more chances of flooding, so it means that it has a positive weight. Similarly, less elevation and less slope means high chance of flooding, so negative impacts. And similarly, if the percentage impervious is higher or if population density is higher, they are contributed as higher chance of flooding, so both of them also have the positive weights here. So just like I talked, we also need alternatives, and for us alternatives are the each of the counties of the Texas state. So all the 254 counties will be the alternative, and they will be ranked by their risk of flooding from high risk to low risk based on the five criteria we have extracted earlier. So this is just the outline of what we are doing in this model. Like Rohan talked about, from Prism, USGS, MRLC, and Census Bureau, we downloaded 5 parameters, 5 criteria of interest for each of the counties. And once we have that, and once we have the complete data set for each of the county for each criteria, what we will use is we'll use the weight, positive impact or negative impacts weight of each parameter, and fit them to the topsis model by creating some sort of weighting criteria. So weighting criteria can either be Perrin-Frobenius AHP or the entropy method. Those two are the methods we use. And to talk in more detail about those methods, I'd like to call in my friends.
Hello, I'm Reena, and I'm going to talk about pairwise comparison and Perrin-Frobenius eigenvector. Pairwise comparison is a method used to evaluate and compare multiple criteria. It involves comparing two criteria at a time and deciding which criteria is preferred or has a greater amount of some quantitative property. So these are the criteria, and we have set it as a pairwise comparison. We took expert opinion from two of our professors, from which we created a matrix to calculate our Perrin-Frobenius eigenvector. Perrin-Frobenius is based on a theory that a square matrix with positive entries has a largest eigenvalue. From the matrix we got from pairwise comparison, we created a normalized row sum which represented the weight for our each criteria. So our weight for each criteria from Perron Fabregas, you can see here. For rainfall it's 0.21, for elevation 0.27, and so on. Criteria with higher weight shows that it is more important than the criteria with lower weight. From our weights from Perron Fabregas as a vector, we can see that percent impervious carries more weight, so we can say that percent impervious is more important compared to the other criteria. So for next part, I'd like to call my friend.
All right, so my name is Jared Marek, and I will be talking about the rest of this project. So with the weights of entropy, these are calculated using the R software. And as you can see, we have rainfall at 0.02, elevation at 0.13, population density at 0.08, and the more important weights ranked by RStudio were percentage impervious, which had a weight of 0.28, and slope, which had a 0.49 weight to it. So entropy is basically the degree of disorder in a system, as we can have a low entropy, which means a lower uncertainty, as opposed to a higher entropy, which has a higher degree of freedom. And when we look at these weights, a lower entropy will carry a higher weight because we're more certain of the variable, as opposed to a higher entropy, which carries a lower weight. Entropy is basically, it's more of a weighting process than it is for ranking, even though the weights are eventually used for the ranking, and it is delivered by using a 5-step procedure. First, we have to make the matrix, and then next we'll normalize the matrix. From there, we can calculate this entropy value, and then from there we can find the degree of diversification, where we can take 1 minus the calculated entropy value, and then we can start the weighting process, which is, like I previously mentioned, calculated using the R software. So as for our results, the left shows the Perron-Frobenius eigenvector weights, and the right shows the entropy weights. Obviously, as our results can show, we have Harris County as one of the highest flood potentials, along with Dallas and Tarrant, which are located in the DFW Metroplex, and Harris County is located in Houston. And with our lowest flood potential, which is more surprising than our higher flood potentials, this West Texas County, it had the lowest percentage of impervious, even though it didn't have the highest, even though it didn't have the lowest population value. So for a comparison, I decided to add the county with the highest amount of rainfall in the last 30 years, which is Orange County, located very, very close to Beaumont. And the eigenvector rank was 15, and the entropy rank was 21. And I wanted to point out a county that was it was really an outlier in our data, El Paso County, which had an eigenvector of 19 and entropy value of 11, where El Paso, Texas was the lowest rainfall county, and Orange, Texas had the highest rainfall in the last 30 years. And this concludes our project.